I start Visual Studio Code. Open CPP 17-2023. I will create a new folder 128 rational. I will create a new file rational.cpp. Hit enter. Ctrl B. Include cpg rational. Include cpg std extension. Void test this with Python. Wrong. So I created a function int main std cout std full alpha. Copy this function name, paste here. Now unsigned A1, unsigned B2, or C A minus B. So C is -1 or something else. If you believe A is 1, B is 2, A minus B is -1, you do not have enough experience in C or C++ language. Anyway, if you think C is less than 0, it is wrong. Let's try std cout A minus B less than 0. Should it be true? If you expect it is true, you are less experienced. Now we can test C less than 0. std and there. I will put one more carriage return. I will open Intel compiler. dir cd 128 rational dp cpp. Don't forget ehsc std c++20 rational.cpp or d.exe. We can use no SYCL. Hit enter. clsd. So it should be false because the type of C is unsigned. std cout type of C is unsigned. We can say cpg GetTypeCategory C std and there. We build again. clsd because the type of C unsigned A minus unsigned B is unsigned int, so this operation failed. If you want to print out the value, you can of course do like this. The reason it failed is that C is garbage value. Now we want to fix this problem. How can we fix this problem? I will copy, paste it here, correct. Before we try correct, copy this function, paste it here. Now we have to fix this part. How can we fix? We know this does not work. I will disable it. Now we can try like this. Plot. Okay. We build again. CLSD. It still failed. How can we compare? We have to do like this. Here we have to plot. We have to fix our code like this. Then let's try. CLSD. Now it is correct. A is 1, B is 2. A minus B is negative 1. To make it correct, it should be less than 0. To make it true, we have to typecast this way. This is wrong. We have to do typecast like this. This has very important significance. Let me give you another example. I will copy this. Copy, paste. I will rename the function. Yes, correct. I changed the function name and paste it here in between. Now scroll up. Please note that we copied this source code from this function. Exactly the same. Now unsigned short. Unsigned short. Okay. This is unsigned. It failed. This is unsigned but short. It should still fail. But I said yes, correct. I will fix like this. Why this failed but I say this is correct. Let's test. We rebuild CLSD. It failed, but this code succeeded. We use keyword auto. This failed when we used unsigned int. When we used unsigned short, this succeeded. Like this. Why? Because of the history. Because of the history of computing technology. When migrating from 32-bit to 64-bit computing, the engineers maintained compatibility with the existing systems. So, integral types less than 4 bytes promote to int. That's why the type of C is int. You have to understand the history of computing technology. For completeness, let me give you another example. Test this with a Python. Still wrong. Now this is int. So we are subtracting from unsigned int with signed int. This is still wrong. I will paste it here. I will copy this command string and paste it here. Now we will try with the clang cd 128 rational clang ++ std c++ 20 rational.cpp. Don't miss ltbb 12 or c.exe. Hit enter. CLSC. So this is first case, this case. This is second case. Unsigned int. The type of C is still unsigned int. So when unsigned and int is operated, the resultant type is unsigned int. Of course, this is intentional design. If we can use int, this problem will be fixed. CLSC now fixed, but we need auto. We need auto. With auto, it fails. Failed. Some people complain about keyword auto, but you can check out the resultant type, the type of C, the type of C, the type of C, the type of C using CPG GetTypeCategory. You can check the resultant type when using keyword auto. If you do not have GetTypeCategory, it might be hard to understand or fix your error associated with auto. But since you have GetTypeCategory, you can completely understand the internals of modern computing device. Some of you may complain of keyword auto, but keyword auto is very useful for the tester when auto is very handy. Now I create a function auto summation auto A, auto B, or I would just say args return args. I simply use parameter pack, also called expression. How can we use this lambda? We do not know return type of this lambda. The best way is using auto s summation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would say S1 copy paste, S2 1.0. Now SED cout S1 SED and there copy paste S2. If you want to know the type of S1, you can always use type of S1 CPG GetTypeCategory S1 std and there copy paste S2, then S2. I will copy this function, paste it here. I will give one more line break. We test once again CLSC. So S1 55, S2 55. For example, 1.5. We build again CLSC, so it works correctly. In case of S1, the type is int. In case of S2, the type is double. At this line, we cannot tell what will be the type of S1 or the type of S2 because its return type is determined by the types of arguments of this lambda. If we don't have keyword auto, we cannot create such function. Don't worry about keyword auto. You can always use CPG GetTypeCategory. Also, C++20 introduced constrained auto. About constrained auto, I will explain in my next episode. Now, I will create another function void test rational numbers. I'm going to using namespace CPG rational numbers. Never ever declare using namespace in the global scope. When you use using namespace declaration, limit the scope as narrow as possible. Now, rational A for 12, paste 12, 3. So, this is equivalent to 12 or 1/3. This is equivalent to 12/3 or 4/1. It is B. SED cout A SED and there copy paste B. Now STD cout A less than B. A is 1/3, B is 4. So I expect this is true. Here A less than B. SED and there copy paste. I will change like this. Copy paste. Now I will change like this. It should be false. It should be false. Fix like this. I will put one more line break. Copy this function, Control End. Paste it here. Now I will copy this command string and paste it here. We build again. CLSC. So rational A 1 over 3, rational B 4 over 1. So this is 4. A is less than B. We expect true. The result is true. A is less than or equal to B. True. True. A is greater than B. We expect false. The result is false. A is greater than or equal to B. We expect false. The result is false. So all these things works correctly. Of course, I defined rational in this namespace. Now watch the pop-up. 16 overloads. I haven't defined this function. Once again, I haven't defined this function. Also, in this case, 5 overloads. I haven't defined this function. I never defined this function. This function, the pop-up says 16 overloads. I never defined this function. Also, never defined. I never defined this function. Never. Now, right-click, go to Declaration. In this function, you can find class rational. In this class, we find this operator. In this operator, I used this operation. This is for testing purpose. For example, if I made it like this, it is wrong. In this case, I rebuilt CLSC. It seems to be working correctly. A, B, true. True. It seems to be working correctly. But what if this is unsigned long long? Unsigned long long. Unsigned long long. Unsigned long long. It does not work. CLSC. I expect true, but false. I expect true. 1/3 is less than 4, so it should be true, but the result is false. If we want to fix this problem, we have to correct like this. Then it will work correctly. Now it works correctly, even if we used unsigned long long. That's why I explained all these things, especially this line of code. I said I created this library to test Spaceship operator. I haven't created this operator. Here I defined spaceship operator. To test spaceship operator, I created rational numbers. I will copy this text. If you want to use rational number that support very big rational numbers, I would recommend you to use MPIR or MPFR or GMP. I explained through this series of videos, I explained how to build, how to use MPIR, MPFR, or GMP on Windows. This library also supports rational numbers. I created rational numbers for small rational numbers for efficiency. Also to test spaceship operator. If I don't understand the history of C++ language or C language, I would have made very silly mistake here, or I can use long double. This is much better. If I don't understand the history, I cannot create correct function. I haven't created this operator, but C++ language gives me for free 16 overloads. 16 overloads. This becomes exponential. So modern C++ language is very powerful. Recently, I came across very interesting article. In Trust, We Trust. Microsoft Azure CTO shuns C and C++. Control click. You can read this article. Microsoft Azure CTO Mark Russinovich has had it with C and C++. Time-tested programming language commonly used for native applications that require high performance. So, Mark, he is sick and tired of C and C++. To this message, Strostrup responses as below. You can read the text by yourself. What I like about Strostrup's message is this part. Evolutionary approaches often succeed where revolutions fail at great cost. What does it mean? Evolutionary approaches often succeed where revolutions fail at great cost. What does it mean? I don't trust anything. I never trust anything without proven track record. They say, in trust, we trust. Or they had better say, in God, we trust. This is myth. They are saying this, in God, we trust. I read this book a couple of years ago. If you think I learned something about theory of evolution by reading this book, you are wrong. Of course, theory of evolution elaborated in this book is amazing. But I learned something more than this book teaches me. In this book, search for cumulative selection. Next, cumulative selection, cumulative selection, cumulative selection, cumulative selection. What does cumulative selection mean? Cumulative selection is another word for evolution. I read this book 30 years ago while I was in military service. The Open Society and Its Enemies by Karl Popper. Recently, I purchased a new copy of this book to read this book again after over 30 years. All I remember the contents of this book is that revolution can never succeed in history. This book says one thing: piecemeal engineering. Piecemeal, 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 piecemeal. Piecemeal, 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 piecemeal. This book says one thing: piecemeal engineering. This book, Open Society and Its Enemy. This book, The Blind Watchmaker. These books are very different. This book is about political science. This book is about theory of evolution or biology. But both of these two books say one thing unanimously or in unison, that revolution, both in human society, also in nature, revolution never succeeds. As of today, November 8th, 2022, we have to wait and see whether the Rust programming language will survive the test of time for next 1 or 2 decades, or doomed to be rusty from its birth.